Okay, so good afternoon, everyone. My name is Candice. I'm the technical support engineer of Supermap, and today I will be presenting the material of Supermap together with my colleague, Danang. He is also the technical support engineer in Supermap. We are from the Asia and Oceania departments. So in today's Supermap mini classroom webinar will be different with before because we collaborate with one of the university in Sri Lanka. Thank you so much for inviting us to join. Thank you so much to join the Supermap mini classroom, and we hope you can take advantage of the knowledge we will share together in today's webinar. Okay, today topic will be discuss about Supermap capability in 3D. They will be divided into two different sessions. The first one is introduction about Supermap and also introduction about the 3D capability in Supermap that can be useful for the smart city. And in the second session, my colleague Danang will be presenting the live demonstration of the 3D operation in Supermap iDesktop. And for participants, will get free certificate from us. It will be sent by email as after the training session today, and you also will get the free trial license. So should you have installed the Supermap before and the trial license is expired already, you can let us know and we will give you the extended trial license. Okay, and one more thing is that should you have any question related with the presentation, you can drop your question in the Q&A chat box and my colleague will have to answer your questions, anything related with Supermap. Okay, without any further ado, I will start the presentation. And anyway, the presentation will be recorded and shared in our YouTube. So if you want to follow the instruction, follow the tutorial today, you can just open our YouTube, maybe 2 days after the training today, and will be shared in our YouTube, and you can follow the instruction to get the hands-on experience by using Supermap iDesktop. Okay, so now let's get started. Okay, first of all, the presentation will be discussing about the Supermap company profile. So maybe some of you are already familiar with us, but maybe the rest is not. So I think will be good for us to get to know about Supermap first before we diving deep into the technical operation. And this will be the outline of today's presentation. The first one is the company profile, and the second one is the Supermap 5 main key technologies, and then the products, and I will be discussing the 3D GIS in Supermap as well. And it will not take too long, I guess, because I hope the session will be more focused on the live demonstration instead of the presentation. So I hope I can make it fast. So as you may know that Supermap is a GIS software company that was founded in the 1997 by Dr. An Jung Song, and we have contributed in GIS sector for 23 years. Open opportunity for thousands employees to coping the GIS problem as our employee, and then already gained more than 1,000 partners coming from then 30 countries, and we have as many as 38 branch offices and subsidiaries. And our technology already certified, so don't worry if you are going to use in our technology because it's already certified by trusted organization. And we have collaborated with so many countries around the world to provide them the spatial solution, or exactly is the GIS solution for them to solve their spatial problem. There are so many countries that have collaborated with us from Asia, especially, and then the Africa and many more, as you can see in this presentation. But this is just an overview for you to get to know about our existing project, because we have been involved in various industries, start from land management, plantation, mining, cyber and security, urban planning, and others. Okay, now I will be discussing the 5 main key technologies in Supermap, and because this is a very basic one before you want to get in touch with Supermap. Okay, so we have 5 main key technologies that act as the foundation for all of our products. It consists of the big data GIS, artificial intelligence, and GIS integration, new 3D GIS. We will focus more on this today. And then we also have the distributed GIS, and the last one is the cross-platform. And we used to abbreviate it as the BDC. Now let's take a look one by one. Start from the first one is the big data GIS. So big data in Supermap has two directions. The first one is the spatial big data, and the second one is the distributed reconstruction of classic spatial data. And Supermap big data support to stream, store, analyze, and visualize large data. Just like in the video in this slide, we try to meet the visualization of location data streams, such as real-time of historical location playback, display, track playback, and target monitoring for aircraft. And it can be also for vehicles and also ships as well. And the second one is about the AI and GIS integration. So one of the AI and GIS integration is on forestry. It can help humans to detect the palm trees. From this case, we can reach the easy way to do the trees counting and other analyze your data that affect palm oil commodity. Moreover, another solution is to detect the footprint of building and clamp it to its 3D model. So we could be able to perform the detection visualization as well as this picture, the right one. Another thing is the estimation of house price affected by infrastructure. So another development, AI can be used to estimate property prices in an area. This is another level. This is another level because of we entering a prediction stage by involving calculating and identifying patterns from the transportation, education, medical, and perhaps the infrastructure data. Okay, next part is about the 3D. So as you can see on the figure displayed, new 3D GIS technology systems are divided into 4 main parts, beginning with 2D and 3D integration data model, which is included several types of data models, such as the 3D points or line or region or solid. And we have also the 2D points, line and region, 3D network, 2D network, TIM, or the interpolated results you ever known before maybe. And then we have also TIN, Voxel Grid. And this will be presenting today about the Voxel Grid. It's very nice, and also grid as well. From the technologies itself, we provide a 2D and 3D integration of GIS, including integration storage, integration analysis, and integration software. You may also ask what kind of data that can be supported in our software. Don't worry, because we provide a multi-source 3D data integration, which you can see in this figure, not only for storing, processing, and analysis, but for the visualization of the 3D data. We provide 3D interaction and output technology using WebGL, VR, AR, and 3D printing as well. Okay. And this is more detail about the data that can be consumed in Supermap. Various type and format starts from oblique photogrammetry. We need to create a configuration file of it first before we open them in iDesktop. Actually, this topic has have been discussed before in the previous SMC. So if you want to know more about this, you can take a look in our YouTube account and you can search the SMC about the oblique photogrammetry to get to know more about this case. And then we also support to open the BIM data or building information modeling, point cloud data, 3D field, terrain that store elevation information, and then we open it in such a scene, modeling, symbolic 3D scene, and also the underground pipeline. Okay. This slide show you about this example of the three-dimensional modeling with its complexity and details. Not only in desktop application, Supermap can bring your data analysis and visualization experience in another clients, such as the web-based or even more mobile phone. But for this case, I will show you the web-based application, which is using Supermap as the engine to allow you display various 3D data and furthermore, put some 3D analysis feature on the platform. The analysis then will be implemented to the data to gain a new insight. Okay, next part is about the distributed GIS. So this is maybe sound too technical, but one of the benefit we can take from this key technology is that it can support for the big data implementation. Because if you talk about big data, the workload is so big, the data itself is so large, has so many variations. So we need to have a technology that can cater that data, and it needs to be divided into the computation need to be divided into several machines. So by using the distributed GIS technology, it can support the distributed computation. But in Supermap, we also have the geo blockchain. This will be very useful for the security of the data. So should you need to secure your data, such as maybe data that related with the land management because it store the legal information and others data that need the security, you can use the geo blockchain to support that. This is one of the example of the geo blockchain implementation is for the cadastral parcel management. So it is easy to implement the trace function of parcel changing based on the geo blockchain. The key data like parcel boundary line and boundary point can be managed by geo blockchain to avoid the malicious modification. And the last one is the cross-platform. So the interesting part is that Supermap can be run in not only Windows operating system, but also in the Linux operating system. And we have so many terminal products start from the mobile phone, desktop one, and cloud-based as well. Okay, the next part is about the Supermap product family. Okay, so we have this kind of product family. We have many kind of terminal product. We have for the desktop, we have for the mobile, we have for the cloud-based. And if you take a look here, from the cloud itself, you have the GIS portal that can provide you map dashboard or making an online map. And then we have also the GIS server or iServer. Will be very useful for you to publish your spatial data. And then iManager, should you have so many server and you want to do the automatic deployment, you can use the iManager. And we have also the iEdge. iEdge is to raise the performance of your machine. And then in the last part, we have the mobile. We have the mobile application. There are two different kind of mobile application. The first one is the one that ready to use. You can just use the existing application. It's called the iTablet, or the second one is the iMobile, which you need to develop further before you using the application. And we have also iClients. It provides a JavaScript API for you to do such a web development. And the last one is the desktop based application. So we have two different desktop application. The first one is the iDesktop.net and the second one is the iDesktopX. The main difference is between two of them is that iDesktop.net can be run only in Windows operating system, but for the iDesktopX, it can be run both in the Linux operating system and the Windows operating system. And in iDesktopX, we can be able to achieve the AI and GIS features, such as to do the object detection or feature extraction, because of it support the Python environments. So in Supermap, the AI, the Geo AI capability, it needs to be supported by Python, and it can be done only in Supermap iDesktopX. But for today demonstration, we will focus more to using the iDesktop.net, and you can download it in our official website, and it will be automatically 90 days trial free in the beginning. But should you have should your license is expired already, you can let us know and we can give you the extended trial license. Okay, and for today's topic, we will discuss about the Supermap solution for the smart city in terms of the 3D GIS capabilities. So if you do talk about smart city, in a smart city development, a city is expected to be able to provide information that is not only available, but also easily accessible and has an element of the intelligence. And furthermore, smart city can provide a more decent life, good quality education, or maybe also job opportunities, a clean and decent environment, and so on. And GIS, which is an abbreviation of the Geographic Information System, this can be found everywhere. Maybe for those whose geodesy and geomatics background are already familiar with this, but basically this GIS is a tool that can integrate various kinds of spatial data for further analysis until obtained results that can be used as a basis for the decision making. The first, we can find GIS in the application of traffic by utilizing vehicle location information, for example, the public transportation such as the bus or the trains, and we can create a location service system with the various features, for example, to inform the customers of bus schedule, notification when there are delays on the road, or if possible, we can arrange a bus that is moving to adjust its speed so that it can get to the bus stop with the appropriate estimated time so that the customer will not miss the bus. And the second is the emergency application. And this can be very useful for dealing with the natural or the non-natural disasters by providing a heat map visualization, for example, which is the result of overlaying variety of other spatial data. We can find out which areas are the most vulnerable of the disaster market in the red, or the safest market. The safest one is marked in the green color. And we can also do the disaster mitigation planning by providing a visual exercise application. And the last thing is social governance. For the government, or urban planning is not a simple thing. It requires various kind of knowledge that are collaborated with each other. With the presence of GIS, we can utilize spatial data from various sources, analyze in 2D and 3D until finally getting conclusions that can be applied in urban planning. And many more. We can also apply GIS for the water application or business application as well. But that are the general about GIS. But what is 3D GIS? So actually I have discussed it before. So I think no need for me to repeat it again, and I can move to the next part is about the BIM and GIS integration. So this will be one of the topic that will be demonstrated for in the 2-day live demonstration. So Supermap is very good. It has very good capability to integrate BIM and GIS. So BIM, which support to representing building and used to preserve very detailed information of the objects, can be integrated with other spatial data to raise the experience of knowledge. And we can get to know how it looks like among its surrounding environment, and it can be the road, it can be the park, air, river, and others. This is the main idea of the BIM and GIS integration. So BIM has the three main components, which is maintenance, planning, and design, and the construction, planning and design and the construction, while GIS is for operation, maintenance, analysis, and resources. To put it simply, BIM is to preserve very detailed information of building. We can get to know each detail of building object and also the texture, and then attach the information, the interior, and other. While GIS is wider, it can be more like describe and define. It can be, oh sorry, I think I make it too fast. Okay, I will repeat it again. So by integrate the BIM and GIS, we could get to insight all at once. the details of specific object and insights on how it looks like among its surrounding. And this is how the comparison between the BIM and from micro to macro and indoor to outdoor. By integrating between the BIM to GIS, you can get the micro to macro visualization and indoor to outdoor visualization. And this is the main processing flow of BIM data in GIS platform. First is to check the data whether it's still stored its original information, such as the geometry, attribute, coordinate system. So I've been highlighting the coordinate system since we import them in GIS. So we need to ensure it has correct coordinate system. Second one, second one is the editing one. As we import the data, we commonly encounter or lose minor representations such as the geometry, texture, and attribute, unless we can edit them to be integrated with other spatial data. And the third one is the optimization. BIM data is usually large, so this will have an impact on the performance, especially if we are going to bring it to a web-based application, so that by implement some treatment as flow, it will help us to raise the performance. The fourth one is the reconfigure, which means a new 3D scene after we pass the prior 3 processes, and the last publish it as a GIS service for web development purposes. Okay. And this is how is BI model represented on a GIS platform. So we support to do to consume this variety of data, such as from the Revit data, Autodesk, the Salt, and others. And for some data that you can see that there is a star mark here, it can be directly imported to Supermap without any conversion or without any plugin. You can just import it to Supermap immediately should you have any data. And we have also S3M or spatial 3D model. So S3M is actually a format that so if you have the 3D data and you want to raise the performance, if you bring them to such a cloud-based platform, you cannot be able to just upload them directly to the platform. You can convert them to the S3M format first before share with others in a cloud platform. And it can be in a spatial 3D model format, because by making this S3M format from your original data, it will raise the performance. And of course, we can apply so many 3D spatial analysis, and this will be discussing in the second session by Danang. We have the feasibility analysis, shadow, skyline, and open, and many more. I think no need for me to discuss so detail about this. I think Danang will discuss more detail about this. And then the 3D spatial calculation. So if you have data, a terrain data, for example, if you have a terrain data and you want to erase one of the parts in the data, and you have another model data to erase it, it can be done also in Supermap. So this is one example of the constructing tunnel through the Boolean operation in Supermap based on terrain entity and tunnel model entity. And we have also the 3D spatial relations. So this can be used for query objects according to the query condition, which includes contained within disjoint, intersect, and so on. So if you're already familiar with the overlay analysis or any kind of things, it can be done not only for 2D data, but also 3D as well in Supermap. And we have, this is for the query. Actually, it's just similar with this. So if you have the 3D model and you want to know which model that are intersected with your defined polygon, it can be done by using Supermap. Or something like this, if you have a case, for example, you want to do the widening road and you want to get to know which part of the building that will be affected by that case, you can do the intersect analysis in Supermap, both for the 2D and 3D data. And BIM, or the building information modeling, will empower the urban planning, because should you have the base map, for example, and you have the BIM data, the BIM data is totally different, because of it just store a very detailed information of your building itself, and by integrate your BIM data to the surrounding environment, it will give you another experience and another insight. For example, you can get to know, if I put a building in this kind of area, it will impact the surrounding area because maybe it's too high, or maybe it's too large, or that kind of things. And okay, for this case, this is one of the example of the BIM data. So this data already bring into a cloud-based application, and we can do such a query for the BIM data. So if you want to looking for the window parts only of the building, you can query that. Or maybe you want to looking for which is the window of the 8th floor only, you can do that in Supermap. And also do this kind of simulation. So this is a simulation of the building development by part visualize, as well as this. So this kind of solution will empower the construction management, such as the simulation that already presented before, and also to do the query and provide some statistics for the clients. Okay, next one is the augmented reality. So in order to raise the experience to see how the data look like in a real situation, augmented reality and GIS integration will be a very good choice. So there are two different AR visualization in Supermap. The first one is by using 1:1 scale, this one, so it will looks like a real scale because it represented in 1:1. And the second one is a small version of your building. So the building information modeling data, it used to be represented in its original size. So if you can display them by using AR, both in a 1:1 scale or not in a real scale, it will be very useful for you to get to know more details about your 3D data. Okay, another need is to express intangible data, such as the sunshine rate, noise field, geological properties field, signal field, and others. So in Supermap, this kind of representation, this one is called Voxel Grid. So it is basically is a regular division of 3D continuous space or phenomenon. It consists of volume. It consists of volume elements. It can be cube, regular, hexagonal prints arranged in regular order in a 3D space. And this is a very simple structure. So it, in a very simple way to say, is that it will create an interpolation of 3D sample point dataset and simulate the dynamic slicing such as the video on the right side. And by using the voxel grid, we can visualize the area which cannot be seen by our own eyes. And this will also be demonstrated in the next part. So this will be very useful to express the sunshine rate, geological properties field, noise field, and many more. And this is more detail about the voxel grid. So actually I have said it before. Basically, this is a regular division of 3D continuous space or phenomenon, and it's very simple structure, and it can express 3D continuous space by using 3D fields, and also we can provide the 3D analysis results. And should you want to get to know the voxel grid result for specific objects such as this one, you can achieve this also in Supermap. So we have the voxel grid, and then we are going to extract the properties, which is the signal intensity, and cover them to the model surface visualization. Okay, I think that's all for today, for my presentation. We can move to the second part, which is will be presenting by Danang. And all of the material for today SMC will be shared in the last session. So don't worry, should you want to looking the material more details, you can just download in the link we will share in the last session. Okay, thank you. And I think we can go to the next part. Danang, are you there?
Okay. Okay. Thank you, Ganesh, and good afternoon, everyone. Danang is speaking here, and it's great to see you on this occasion. As already explained in Supermap, technology allows us to support the planning and development of smart city. And I will add a little introduction. Okay. This overview, I will start with a centralized information system based on GIS or Geography Information Framework that integrates not only every stakeholder but also every aspect of smart city processes. And starting from conceptualization, planning, and development to maintenance. And speaking about planning, design, and visualization, or we can call it as geodesign, will be the key framework for conceptualizing and planning for smart cities. And it will assist at every stage of project conceptualizing to site analyze, design specification, stakeholder participation and collaboration, and evaluation. And GIS enable us to integrate a variety of data from multiple sources such as road, sewerage, and drinking water, and to perform spatial analysis and planning. With this type of capabilities, GIS is an essential component of the engineering information system of the future. And a 3D geographic information system can be used to create a realistic simulation of a project, environment, or critical situation. Okay. In this afternoon, I will do a live demonstration to you about 3D GIS capability on Supermap. And for the software, we will use it in Supermap iDesktop 10i 2020, and you can download it on our website at www.supermap.com. Okay. In order for all of us to understand the demo, I will show you through the following workflow. The number one is generate 3D model from 2D. The second is screens. The third is analyze daily. And the last one is a feedback for 3D data. Entering this workflow, first about the iDesktop Supermap interface. Okay, as you can see that this is the interface of Supermap iDesktop 10i. And this interface adopts ribbon styles like Microsoft Office that organize its tool function with a menu and with toolbars. And related to data management in this workspace manager, Supermap manages various data in Workspace Manager by using the concept of tree structure, which consists of the first one is we work with our data, and the workspace has format. The format is SMWU, and for the data source. Data source is the place where we store data sets of different types. And the format is UDB. And to enter the data set, we can create a new file data source, or we can open file data source. And we also provide various of type data like shapefile, geodatabase, AutoCAD, Leader, and many more. And the next is maps. The maps is where to save our created map in the map window. And for the layout, where to save the scale, legend, arrow, and etc. And the next is scenes. Scene is where to save our 3D scene created in the scene window, and model, and also resources. And the resources is where to store marker, symbol library, line symbol library, and fill symbol library. Okay, I will uh, I will start with our first goal. Okay. In this section, we have 2D data that has height information. And with that information, we define the height to make it 3D and give it a touch of visualization to look good. Okay, back to iDesktop screen. We can open the existing folder by right-click and then open file data source. We can open a Voxel Grid and choose MLCDB that has a UDB file type. And then click open. And once logged into our data source, select the VBM. This data sets, and right click, and we can add to new map. Okay. This is a display of the VBM dataset in 2 dimensions and has not had any height. So we can close it. And then for attribute table, we can check in browse attribute table. And then with BM dataset has height information in this column. So we can define from two-dimension data to 3D data. So the next step is we can add with BM dataset into a spherical scene. So right-click in with BM and then add to a new spherical scene. We can zoom to layer by right-click in this layer management, then zoom to layer. Okay, now we can view the with BM dataset on 3D visualization, but this dataset hasn't had any height information. So we can select Style Setting tab. After select Style Setting, we can select for altitude mode and choose the okay, In absolute mode, we select absolute mode because we want to have a relative height to the sea level. And then for the lift height, we can choose this one, the height. All right. So as you can see, the with BM dataset has a height in each building. So, and this is the view of with BM datasets, and yeah, now has a variety of heights in each building. The next step is in order to have an interesting visualization of these our building, we can add the appropriate building picture. We can select in style setting tab, and then there is a texture setting. So now has appeared the 3D texture manager window. We have side texture and top texture. So if we want to add some picture to give the texture, so we can add it on texture file, and then we can choose the select file. I already have some picture to make as our texture. The first one is I want to choose building 10 as our side texture. Okay, beside that, we can define the tiling U and the tiling V. For example, I want to change the tiling U from 1 to 5, and then the tiling V, I want to change it on 3. So it more be realistic now. And then I want to define the top texture. Select on texture file, and then click select file and choose the picture. And for example, I want to choose a ground underscore 7. Okay. So after this step, the texture setting step, so we have finished first goal, which is generate 3D model from 2D data. Okay. As you can see, in the second part, we are going to work using Voxel Grid data. And as Gandhi said, that Voxel Grid is another geometry type in 3D that is defined on a regular 3D grid. And through this data, we will visualize the Voxel Grid to determine the level of distribution and intensity. So we are going back to our iDesktop screen. Okay. Yeah. Yeah. We are still opening the same scene window. And in the RCDB data source, there is a data set point, right, in Workspace Manager in this one. So we can add it to current scene. Okay, wait a moment. It's still processing. Okay, this is the visualization of our point. This is a Voxel Grid point. Okay, before we move on to the next process, I will open the attribute first of point data sets by right click and then rows attribute table. And I want to check the attribute information of a point. So there is a grid LSTV column and there's a bottom height column. Okay, in this attribute, we can see for grid elasticity column, where grid elasticity is the value of the voxel grid. And yeah, we also see there is a high column which has a value range from 0 to 40, I think. Yeah. So grid elasticity will make as an eigenvalue for the next process. Okay. So many the data in this data set until 900. So with Supermap, if we want to processing using Supermap in 3D processing, it will be more efficient because the processing just effective and not need longer times. So we can close it. And then we can select the 3D data tab. And then there's 3D grid. And after we select 3D grid, there's generate 3D grid. We can use this function. Okay. Okay. On this occasion, I will only use one of the methods here. That is IDW, or we can mention it by inverse distance weighting. And some of the parameters, the first one is source data set. We can change the source data set points because we want to process the voxel grid using points data. And then for the eigenvalue, we can choose grid RSCV. And the next is we can change the section height 0. And then for split distance, we can change it into 10. And for 5 is slice count is 5. Okay, by setting it like this, we can have heights ranging from 0 to 40, just like those in the height column, right? So if we already change this generate 3D grid parameter, we can continue our processing. Okay, once the process is complete, we will get a new data set that is data set volume underscore 1. This is the result of a generate 3D grid. And then we can right click and add to current scene. Wait a moment, still processing. Okay, I will turn off the other layer, such as with BM, and then points. This is our result voxel grid. So yeah, And then for the uninitiated, for the participant who wants to change the color and then like the style, we can change into layer properties by this one. Data set volume, and then right click, and then we can choose layer properties. Okay, wait a moment. Yeah. So in the layer properties window, there are two nodes. The first one is basic and the second one is 3D grid. We can select the 3D grid, and then there is some parameter setting in this node. The first one is basic info. We can change the voxel size from 1 to higher, and then we can change the scale, transparency, and also we can change the color table. For example, I will change it into the other color, such as ZM underscore chance till orange. Then click OK. And the visualization of the voxel grid has changed. Okay, and then the next parameter setting is display slice profile. Yeah, and this slice profile in this display slice profile setting, we can crop the profile on each coordinate value. It is X, Y, and Z, so that if you want to know the value of voxel grid in a certain area, you can use this one and just the set numbers of each coordinate only. Okay, I will turn on the other layer. Yeah. So the voxel grid, we can make such as temperature and then wine as our voxel grid data. So we have finished getting the voxel grid from 3D points. Can on the next goals, we to use another data, so we can close this scene window and not necessary to save this scene. And also we close the MSCDB data source. Well, we would like to work on another data. The first one is, and then the second one is a small town. It is CBD. Okay. Okay. Yeah. In this section, we will work using the EM data to perform basic mapping analysis such as slope and aspect, and then Invisalign, flooding, and profile analysis. Then we will also work using data to perform other 3D analysis such as shadow, skyline, and manually. After open our data, we can select the DAM 25 way back share screen, iDesktop screen. In this DEM data source, we have DEM 25, right? So let's select the DEM 25, this one, into new spherical scene. We can add it as terrain and also as image. After that, we can zoom. Yeah, after we make this data as a terrain and as image, we can move to next step by select the 3D analysis tab. Yeah, all right. Yeah, we can see there are many analyses available in Supermap iDesktop 10i 2020, and then we will try one by one for this analysis in this DEM data. All right. We can move to first analysis. The first one is slope and aspect analysis, right? We can select slope and aspect analysis. And then we can draw a polygon to proceed slope analysis. Make it. And we can finish our polygon by right click. All right. Yeah. Uh, as you know, slope and aspect are two important terrain factors, like playing an important role on terrain surface analysis, in which slope denotes the measurement of the ratio of height change of a certain location on the Earth surface. And for the direction of slope change is aspect denoting the measurement of change of slope direction of a certain location on the Earth's surface. So beside that, we can change display setting. By the first one, we can see just slope mode. And then we can also see just aspect display. Okay, the aspect is drawn by arrow, and also we can see between slope and aspect together. Okay. Okay. This is the slope and aspect analysis in Supermap, and we can delete this analysis and move to the other analysis. For the second is we want to try to use isoline analysis. We can draw a polygon to proceed isoline analysis. Yeah, Yep. We still make it on a polygon, right? So in 3D spatial analysis, you can generate the contour from the raster like DEM, and the raster can be DEM, or the raster can be grid data set. And on the right side, we can set some parameter this setting like display mode, and then line color, the transparency, the minimum visible altitude, and also the important thing is we can change the interval. For the example, we can change into 100. Yeah, as you can see, the isoline has changed. So the for the isoline analysis, we can set many setting for display contour mode, like this one, and also texture filling and blend mode. So if you use isoline analysis in Supermap, it will take faster than the other. Okay, I want to delete this one. Then we can move to the other analysis. It is flooding. Okay, for the flooding analysis, we can make some polygon too, like isoline and slope aspect analysis. For example, I want to make a polygon in this area. You can finish it by right click. And then the current altitude is being changed, as you can see. And then there will the water from the surface. Okay, the water has appeared. This is the flooding analysis and the flooding visualization. So this function is used to stimulate the flooding process over a duration of time with the specified speed and with the maximum speed. And in this setting, we can set related to about the height and for about the speed. We can set the minimum visible altitude, and also we can change the speed of the water. All right, you can delete it. And for the last analysis using DEM, we would like to use Probabil Analysis. In this Probabil Analysis, we just create a cut line to operate. For example, I want to see the Probabil from the start point until end point. Yeah. So the Probabil shows the change of elevation along the line, along the section, and the results of the Probabil terrain, geology, and hydrology. For example, including the landform, outline, absolute and relative elevation, and then the other thing is geologic structure is very useful for the estimating of the feasibility of the building railway or the difficult for building road. And it can also provide a foundation for calculating volume. So this Probabil analysis, we have done using DEM data, and now we can close this window and move on to the other data. Okay, in the CBD data source, we can add all the data sets into our spherical scene. And then we can zoom to layer to water. Yep, all right. As you can see on your monitor, this is a small tone view that exists in CBD data search. And each of the object is indeed created exactly and as beautifully as possible to get the maximum visualization. And so we will start the first step by selecting the waters in this layer manager, and we want to change this symbol by right click, and then we can select the layer style, and then we can choose the 3D fill, and the next one is fill library 3D, and there are four symbol of the water, like still water, slow water, rushing water, and cold lake, right? So I want to choose this one. All right. Yeah, as you can see, the layer from waters now has a good visualization and now looks dynamic because the water like is moving, right? So it more be realistic. Then we will do some analysis, especially 3D analysis in Supermap iDesktop. And of course, of the following analysis will be useful for smart city capability. And I will show you our first analysis. The first one is fused analysis. In this CBD data source, we will use some analysis. Uh, the first analysis is fused analysis, and then dynamic fused, and the next one is feasibility, shadow analysis, and the last one is skyline analysis. So we will start it using fused analysis. Right. We want analysis in this road. Right. For fuse analyze, we can draw start point and we can draw the end point. For example, I will start the start point in this area until, yep, all right. Okay, this is a fuse analysis in Supermap. So in this analysis, we need, as I said that we need a start point and end point, and this function is used to identify visible and invisible range in the analysis area of the observer point at horizontal and vertical angles of view within a certain radius. So the visible is colored in green, right? And and for the invisible, it's colored by red. Yep. Okay, we can continue to next analysis. We can okay, we can draw again to perform fused analysis. For example, I will draw on another road. For example, in this part, can draw again. Yeah. All right. So this is the fused analysis, right? We want to move to another analysis in Supermap IDEX stuff. It is dynamic fused. We can make a start point and end point in this road. Wait a moment. We can finish our drawing by right click. Okay. Actually, almost the same as fused analysis, but the difference is that the object in this analysis will move from one place to the other place along the way. And as you can see, these analysis get an overview of the object that cross from a road related to how he views. And because there is a dynamic color along the way. We can and also we can change the role of the view. We can change into car, maybe, for example, or we can choose female, or we can make it as another object. For example, we can car. Yeah, this is the view of dynamic views of this car. All right, we can close it again. And for the next one is feasibility. All right. Yep. In the previous analysis, we used highway, and now we use road. Now we use buildings. Okay, we can search the building. For example, this building. Yeah, we can choose the feasibility analysis. And for example, I want to see the feasibility on the fourth floor. This one, and then draw the start point, and we can end it by draw the end point, and also we can draw another line. Yeah, as you can see on your monitor, there are four line, right? And then has a different color. So we can imagine being on a certain floor and looking at a point in a number of area, and it can be concluded that this analysis is an is an analysis to identify area that can be seen from one or more observer points or with relative height by knowing the distance and the direction of the observation. Yeah. Okay. This is the visibility analysis result. So we can change to other analysis, I think. So we can move to shadow analysis. All right. But the first I will change. I will zoom to layer into a building layer because in shadow analysis we need a large area such as this one. We can select shadow analyze, and then we can draw the polygon in this area, and then we can finish it by right click, and we can see we can see the result. Yeah, it's still processing. Yeah. Okay. As you can see, this analysis is used to calculate the duration of sunlight in a period of time in a specified area. So that the more orange, the more it has a high intensity of sunlight. So and the more blue, it has less intensity of sunlight. And also in this parameter setting, we can define the minimum height and also we can define the maximum height. And for the time setting, we can start time in the hours, and the end time we can change it into date and hours. For example, I want to change the maximum height to 30, and then we can perform the analysis. Wait a moment, it's still processing. Yeah, the height of the shadow has changed now. It is more higher. So that is the shadow analysis to view the intensity of the sunlight. You can delete. And for the last analysis, it is a skyline analysis. We need a clear area. For example, we have observer point in this area, like this one. Okay, and then after that we click the skyline analysis, and we will show the result. For example, skyline analysis. As you can see, we have a blue line, right, in the monitor. So this analysis is allowed to you to describe the city skyline as seen from the observer point, and the result of this horizon will show the boundary between the top of the building and the sky. Yep. Okay. So we have been working on the 3D analysis that in Supermap. Next, we will move on the last goal and keep using this window. I will share the PowerPoint. As you can see, we already performed for this one for the ISO line, and then we also already did the feasibility and views analysis and the shadow analysis, and the last one is skyline analysis. So it will be useful for perform in urban areas management. And then we can next to our last goal, it is achieve a beautiful effect for 3D data. Okay, in the last section, we are going to add some particle object in Supermap to give beautiful effect to our 3D data, so that it looks more realistic. Okay, we can move to iDesktop screen. We still are using this window. For example, I want to zoom the water layer. But before that, we need to create a new data set on the CBD data search by right-click and then new data set. All right. There will be a new data set window, and we can change the type to cat, and also we can change the name dataset, the dataset name. For example, I want to name it as effect, and don't forget to use the template of the coordinate, because we want to work on CBD data search. Of course, we can select CBD data search, and then for the data set, we can choose anything in this data set. For example, I want to use a grown data set because we need to similar set the coordinate. So for right now, we have same template of the coordinate system, so we can create. All right, we have effect dataset on CBD data search. We can add to current scene. It has moved to general layer, and effect can draw the particle object. So in the first one is we need to activate the editable layer by double click in this pencil symbol, or like this one, or by right click and then editable. So the editable has active on the effect data search. All right. After that, we can move to drawing tab, and there is a particle object group. In the particle object consists of fire, explosion, rain, snow, fountain, smoke, fire and smoke, tail until fireworks, right? So okay. So the first particle object that I want to draw, it is fountains, and for our last goal, we don't need to activate or draw all of the particle object. For example, I want to use fountain, fire, and the third is rain, I think. Okay, I want to draw the fountain. Maybe we can place it on this area. Okay, just click on any area, and then you can see the result. We can make this lake more beautiful with the tree fountain, right? Yeah. And then for the other object, we can draw fire maybe to imagine if there is a building has fire explosion. We can visualize, for example. Yeah. Okay, this is the visualization of the fire, so that we can get an overview of the visualization. And maybe for the last particle object, we can create a rain, I think. Okay, maybe we need a larger area to create a rain. For example, this one, and then we can finish by right click. All right. As you can see, we have a heavy rain in the area, right? Like this one. So I think it is needed to visualize more beautiful and more realistic of the smart city, because it will make a comprehensive reference in our data management, in our decision. Okay, I will back to our last screen. So yeah, all right. Since we have reached the last goals, then this live demonstration is over. Hopefully, this demo can be useful for you and add new insight, especially the 3D analysis in Supermap iDesktop 10i 2020. So if you have any question for this demo, you can contact me on my email at danang@supermap.com, and also you can contact me at LinkedIn, Danang DN, and you can download the material in the Drive Google. I will share this Drive Google link on our chat box. Okay, that's all from me. Thanks for watching this demo, and see you next time, and good afternoon.